European scientists are turning an aircraft into a laboratory that simulates lunar gravity, and Space.com has taken a ride aboard this plane with them. There is only one way to experience the feeling of being on the moon while still on Earth, or rather a few thousand feet above its surface, in a parabolic flight.
Only parabolic flight can reproduce the Moon and Mars gravity. There is no other facilities. Other facilities only simulate, but not recreate the real one. On board our plane, this is a real gravity field.
There are a couple of drop tower type solutions that can do lunar gravity on a very, very small scale, but only for a couple of seconds and only for hardware. If you want to get people into lunar gravity, you have two options. You can either come on this aircraft or you can go to the moon. That's it.
Parabolic flights, best known for producing weightlessness, follow a wild trajectory of fast, steep climbs and short, carefully managed free falls. During those free falls, objects inside the plane experience either brief spells with no gravity at all, or, if the pilot flies the parabola just a little differently, reduced gravity.
We'll fly this aircraft like the aircraft is falling down, but not too much, to keep just the gravity we need. 0.16 g for moon gravity or 0.38 g for March.
The French company Novespace, based in the famous winemaking city of Bordeaux, is Europe's only operator of parabolic flights and prides itself on their ability to generate lunar or Martian gravity conditions with scientific precision. In the last week of April, scientists from all over Europe descended upon Bordeaux's airport and turned the Novespace plane into a lunar gravity research lab. Until recently, there's been more demand for flights that produce weightlessness. But with the renewed interest in moon exploration, spearheaded by the NASA-led Artemis program, the need for artificial moon-like conditions is on the rise.
This is the first time that the European Space Agency is doing a full parabolic flight campaign in partial gravity, so we do lunar and Martian because of the request of all the experimentators and participants. Of course, we are most interested in the lunar environment and lunar partial gravity because this is what will help us to prepare for the moon exploration.
Scientists know quite well what no gravity does to human beings and technology, thanks to years of research on the International Space Station. But they know very little about the effects of the moon's gravity, which is 1/6 that of Earth, or Martian gravity, which is a little stronger than 1/3 of Earth's gravity.
We know only very little about the effect of the effect of the moon gravity or life on the moon on the human being, since we were on the moon for only really limited period of time. And there's an additional factor about it, because we cannot simulate moon gravity on Earth so easily. For instance, BEDRES studies, we know they can simulate microgravity, but no one really knows what is the right condition to simulate lunar gravity, and neither Mars. So we are really in a kind of still black box where we don't know exactly what the human being will be faced to and how he will cope to these conditions on the moon when he stays more than a few days, I would say.
Each reduced gravity spell during the flight lasts just under half a minute and is preceded and followed by 20 seconds of hypergravity when the plane speeds up and steeply rises, and then when it recovers from the free-fall state. During one flight, the plane performs 30 such maneuvers, with only brief periods of steady flight in between. By carefully analyzing what happens with the experiments during these short periods of reduced gravity, scientists can gain a better understanding of what might await future moon explorers. In this experiment, scientists are filming the behavior of human immune cells inside special containers. The researchers know that in weightlessness, immune cells struggle to reach the infection site, which makes astronauts more prone to illness. Now they want to know whether the same effect occurs in lunar and Martian gravity.
We have seen, at least in this experimental setting, that when there is really no gravity at all, we have a centralization of the cell flow in the middle of this flow chamber. So they were faster and centralized. So to get in contact with a vessel wall, might be already because of this much harder. Yes, and now we are just investigating the same issue in lunar and Martian gravity.
On board the flight is also a 3D printer that uses a type of plastic mixed with simulated lunar dust to print simple tools. This is the first time researchers are testing its performance in lunar gravity. But the most interesting piece of equipment on board is this vehicle, developed by a team of researchers from the European Astronaut Center in Cologne, Germany. It's called LISA, for Lunar Equipment Support Assembly, and it's essentially a lunar wheelbarrow that may one day help astronauts on the Moon transport equipment or injured crew members.
Is it difficult to operate something like this on the Moon?
It's not really difficult to operate it because it's much lighter, because of the lower gravity, but it's more difficult when you have uneven terrain.
Stevanin and his team created a little obstacle course inside the plane to test 3 versions of LISA during the parabolic flights. Here, European astronaut Thomas Pesquet has a go operating LISA in Martian gravity.
So what we want to test is how an operator, an astronaut, let's say, in lunar gravity will work, what is a locomotion that will be applied to pull and push this kind of equipment, and how the equipment will react over an uneven terrain, and how you have to control it. This will give us some feedback to improve the next prototype, next generation, and to define, is it better with 4 wheels, is it better with 3 wheels, is it better to have 1 handle, 2 handles, what would be the best configuration.
Astronauts train in parabolic flights to prepare for weightlessness, which they experience on the International Space Station. But the Novespace plane, which is the largest in the world capable of flying parabolic flights, could in the future be turned into a sophisticated training ground to prepare astronauts heading to the Moon. In this experiment, Stevanin and his colleagues perform simple tasks in lunar gravity while wearing a virtual reality headset running a simulation of a region near the lunar South Pole where future Artemis missions will land. In this case, the test subjects move a box of tools that they see in the virtual reality simulation, but which is also physically present in front of them. In the future, the setup may become more complex and include, for example, the LISA wheelbarrow and a physical mock-up of a lunar lander.
When you wear this headset, the resolution is so high that it's, wow, I'm on the Moon, it's really impressive. Now, if in addition, what you try to grasp is you have the virtual, the partial gravity that is added to the virtual environment, and when you want to move around, you move like on the Moon. You are really embedded into it. And we are convinced that there is a high potential for astronaut training in the future, combining these 2 technologies.
The Artemis program expects to land humans on the Moon in 2025. By the end of this decade, NASA plans to build a permanent base camp near the lunar South Pole that will host crews of 4 astronauts for up to 1 month. For comparison, the longest of the Apollo-era landings 50 years ago lasted barely 3 days.